Welcome to the NIME workflow named Data2. This workflow uses the customer scores database with missing data to illustrate different missing replacement techniques. The workflow starts by loading the customer scores database through the file reader node. We use also an interactive table node to show that the customer scores database contains missing data. To this extent, we right-click the bottom of the mouse and we select the View Table view. The window opens, the interactive table window opens, and we can see that the dataset contains missing values. For example, the row with the row ID equal to row 2 for the attribute account length is equal to question mark. We can, however, find all the missing values with the navigation command and finding the string question mark and pressing the button OK. Then we can also find other missing values simply with the F3 keys as I'm doing now. So we know that the customer calls database contains missing data. Let us now present different options to solve the missing data problem. The first one is the record elimination, and we know it consists of eliminating all those records where at least one missing value is present. In particular, the missing replacement technique are implemented in NIME with the node missing value. This node can be found in the section of the node repository. However, to show an additional feature of NIME, we will simply search for the missing node using this search tool, and we find that the missing node, the missing value node, belongs to transform, to column, and in particular to data manipulation section of the node repository. Then to set up the missing value node, we right-click the bottom of the mouse and we select the configure option. Now this window opens and we can specify which is the strategy for the integer attributes, for the double attributes, so continuous attributes, for strings attributes, and also for unknown attributes. In our case, we made the decision to implement the record elimination, so for each of these types of attributes, we always select the radio button remove row, as can be seen from this window. Then we simply confirm our choice with the OK button and we execute the missing value node. The output of this is connected to an interactive table node whose output is used to check that in this dataset, in the processed dataset for the missing replacement applying record elimination, no more missing values are reported. This can be ensured again by using the navigation command, using the find option and searching for the question mark, and we will find no any occurrence of the question mark. It is worthwhile to mention, however, that using the record elimination we moved from a number of records which is equal to 3,333 to a number of records which is equal to 1,924. This means that more than 40% of the observation of the records of the customer scores database have been removed. The second option consists of using a global constant. In this case, again, we use the missing value node and we configure this missing value node using the option, the radio button associated with the option fix value, and this is applied for all different types of attributes. In particular, we will use 999 as the symbol for missing value for all the integer and double cases, and we will use the string anc for the string columns. Then again, we close this window, we execute this node, and we can check whether the missing replacement worked correctly with the global constant replacement, again by selecting the view table view option. In this case, we can check that the missing values which were associated with question mark are now associated with 999, 999, and we can find again using the navigation menu again all the occurrences of the missing values with the new representation. We can now close this window and we can move to the third option for missing replacement, which is represented by mean and mode or most frequent replacement. Again, we use the missing value node, but now we configure it in a different way. For integer and for continuous value, we use the mean radio button selection, while for strings we select the most frequent radio button. And again, simply executing this node will result in the missing values replacement. In particular, again, using the interactive table, we can simply select the view table view option, and we knew that the row with the row ID equal to row 2 for the attribute account length was characterized by a missing value that now has been replaced with the mean of all the observations of account length that are not missing in the dataset. The same can be shown for the attribute day means, eve means, and so on, and also for string attributes. Let us now concentrate to the presentation of the last two missing replacement techniques: conditional mean and most frequent replacement and the most probable replacement. Concerning the conditional mean and most frequent or mode replacement, this is implemented through a meta node that is called conditional replacement using churn. Indeed, we use the class attribute churn to implement the conditional missing replacement. As already told, we implemented this through a meta node that can be accessed by left-clicking in rapid sequence on the node. So once we have rapidly clicked on the node, we access the definition of the meta node. This meta node is characterized by one input port and one output port. In particular, the input port receives the input data, so 3,333 observations from the customer calls database, and now we use this node nominal value row filter, which allows to select only those observations, only those records where a given attribute takes a specific value. In our case, we access the configuration of the node as follows. The attribute used to select the records is the attribute churn, so the class attribute, and we select only those records where the class attribute churn is equal to n. On the other side, we have that the nominal value row filter is used to select only those rows where the churn attribute is equal to y. Once we have partitioned the dataset in these two subsets, then we apply on each one of them again the missing value node. In particular, we configure the missing value node again as we have done with the mean and the most probable replacement. We select for integer and double exactly the mean radio button, so using the mean to replace the missing values. For the string we select the most frequent or mode as already done before. This is done also for this lower flow. And finally we use the node concatenate to join back these two subsets. Then we can close the meta node, and again also in this case the interactive table node is used for inspection purposes, so to check whether the conditional replacement using the churn attribute works properly. In this case we access the output selecting the view table view, and we can use again the navigation to find eventually the missing values, but also in this case we will not find any missing values, so any question marks, because we have correctly applied the conditional mean and most frequent replacement. The last missing replacement technique is the most probable. In this case we use two nodes, two row filter nodes. The row filter nodes are such that they allow us to filter out rows where specific conditions are met. To configure the row filter node, we right-click the bottom of the mouse, we select the configure option, and in this case we make the decision to use as a test column, as a test attribute, the attribute vmail message, and we select with the radio button include rows by attribute value, and in particular only missing values match. So in this case we simply select all those records where the vmail message is equal to missing. These other row filter nodes is the complement. Indeed, in this case, the configuration consists of excluding the rows that are associated with missing values. So here we select missing values records, and here we select the non-missing record values. Then, once we have selected a subset of the customer score database consisting of no missing values, we develop a most probable model. In our case, we make the decision to use a linear regression learner. Linear regression learner can be found again using the search tool of the node repository, simply by writing linear regression, and it is under the section of statistics. This node is configured as follows. We select configure option, and we use the vmail message as the dependent variable, so the variable to be predicted, so the variable characterized by the missing value, and we use the vmail plan, one of the remaining attributes, to predict the value of vmail message. So vmail plan will be used to predict the value of vmail message for those cases where vmail message is missing. We select no additional parameters here, and we confirm our choice. Then we run the linear regression model, and we apply the linear regression model using this linear regression inducer to those observations, to those records where the vmail message value was missing. So using the predictions coming from the linear regression model to fill the missing values for the vmail message. In particular, we use this column filter to remove the old vmail message attribute and we use the column which is named prediction vmail message, where the prediction offered by the linear regression model concerning the vmail message attribute is given. So we simply rename this prediction vmail message attribute or variable with the old vmail message variable. Then we close this workflow by concatenating back the set of data where no missing values were reported for the vmail message with the set of data where the vmail message was characterized by a missing value. Once we have concatenated these two portions of the data, we again use the interactive table node to check whether all the operation was fine. So again, we select the view table view, and in this case we can check again whether the replacement has worked properly. In particular, we move to the last column, which is the column where the vmail message is allocated, so the value of the vmail message are allocated, and here we will have the predictions of the value for the vmail message. We also have to underline that in this case the number of observations we obtain is equal to the number of the original observation, original records of the customer scores database, while in the case of the conditional mean replacement we have not the same, we do not achieve the same result, because indeed here we have 3,241 observations. Why we have no 3,333 observation here? The answer is simple, because in this case we add a given number of records where the variable that we have used, so the churn attribute, was missing. So all those observations or records were discarded and no longer available in the interactive table, so after having applied the missing replacement technique.